Hello children, continuing in the chapter real numbers, let us now come to the important part of how to find the highest common factor and the lowest common multiple of given 2 or 3 positive integers. So for that, I will just tell you first what actually do you mean when you are finding the HCF. For finding HCF, that is the highest common factor, you need to prime factorize the numbers first. That is what I am going to show you. But once you have prime factorized it, that is you have found all its prime factors, then from the prime factors you have to take the product of the smallest power of each common prime factor in the given numbers. That will decide your highest common factor. So the important things are, you have to take a product of the smallest power of each common factor. This is important for highest common factor. Now once you have prime factorized, suppose you have to find LCM, that is the lowest common multiple. What are you going to see? You are going to do the product of the greatest power. See the difference children, here it was smallest power, here it is the greatest power of each prime number. Now here it was each common prime factor, whereas here it is each prime factor. So all the prime factors you are going to take, but they should be with the greatest power only involved in the numbers. So that is how you find LCM and HCF of given 2 or 3 positive integers. But the question is how to find its prime factors first. Now you know very well children that 2, 3, 5, 7, 11, 13, 17, these are all the prime numbers, right? So whenever you are doing prime factorization or you are finding prime factors of the given number, don't forget that these are the numbers which I mentioned just now are the ones to be used. So I am just giving you 2 questions over here. It says express each number as the product of its prime factors. In a way they are saying that we have to do the prime factorization of these 2 numbers, and once children you know how to do prime factorization, then I will tell you how to find the HCF and LCM of the given numbers. But let us first know how to find prime factors. Now to find prime factors there are 2 ways I am going to show you. So whichever way you find easier you can follow. So let us come to the first question, 140. So I am taking the question over here, 140. Now one way of finding its prime factors is children, just writing it over here, 2 into 70, right? 2 into 70 is going to give me 140. So mentally you have to divide 140 by 2 and you will get the answer 70. Now when I see 70, again why did I choose 2? Because I told you the prime numbers are 2, 3, 5, 7, 11, 13, 17. This is how you have to go in that order only. It's better if you follow the order. So now 70, I know 70 is divisible by 2. Now you will say 70 is divisible by 5 also. Yes, but then we always give priority to the least number first and then we go to the greater numbers. So it will become 2 into 2 into 35. Hope I am clear over here because 2 35s are 70. Now when I see 35, it goes directly by 5, neither by 2 nor by 3. So I choose the next prime number as 5. So it will be 2 into 2 into 5 into 7. And once I do this, I know that these are all my prime factors or prime numbers, and hence my prime factorization stops. This is one way of doing it. Other way of doing it is you do it vertically. That is what I am going to show you now. So I am going to show you over here, if you have the number 140 and you have to prime factorize it vertically, then how do you do? Procedure is the same children, only the way of writing is different. So I first try with the least prime factor, which is 2. Now I know 2 7s are 14 and 2 zeros are 0, so 70. Again it goes by 2. Now again I told it can go by 5 also, but take the least prime number first. So 2 35s are 70. Now 35 goes by 5. So I will do 5 7s are 35 and then 7 1s are 7. So till I get 1 over here I need to go on doing it. So 2 2 5 7, 2 2 5 7, these are the prime factors. But then how do you write it? Therefore 140 is equal to, now since 2 is repeated over here children, how do I write? Is equal to 2 square into 5 into 7. So this is how you find the prime factors of the given number. Since the 2 is repeated over here and repeated over here, I will write it as 2 square. So these are the final prime factors of 140. Now let us go to a little bigger number. Now the thing is, the number, now here your divisibility test should be good. Now when I see the number, it is not divisible by 2, neither it is divisible by 3. Why children? Because 5 and 5 adds to 10 and its total again is 1. So it is not divisible by 3 either. It is not ending with any even number, so it is not divisible by 2 also. So my next prime number is 5, and yes, its last digit is 5, so it is divisible by 5. So it will become how much children? 5 into 5 ones are 5, then 0, 0 and 1. Don't forget about these zeros over here. Okay, so 1, 0, 0, 1. Now how do I try with which number? I'll try by doing it by 7. So 1, 0, 0, 1. If I divide by 7, how much I am going to get children? 7 ones are 7 minus 3 over here, 0. 7 fours are 28 and I get a 2 over here and a 1, and 7 threes are 21. So I told you, go in order 2, 3, 5. The next number I have given priority to is 7, because 1, 0, 0, 1 is divisible by 7. How do I write it children? 5 into 7 into 143. Again going ahead, 2, 3, 5, 7 done. Now the next number is 11. So I'll try with 11. 143 divided by 11. 11 ones are 11 minus and 3 over here 33, and it goes by 11. So 11 threes are 33 minus and remainder is 0. So how can I write it children? 5 into 7 into 11 into 13. Right? So this is how your prime factorization is done. Same way you can do vertically as well, the way I have told you. Procedure is same. Again I start with the number 5. How do I do? 5 ones are 5, 0, 0, 5 ones are 5. Again I know it goes by 7. So I will do 7 143s are 1001, and then I know it goes by 11. So 11 13s are 143 and 13 ones are 13. I told you, for a vertical prime factorization you have to end with 1 over here. Now when I see these factors children, all are different factors. So there is no greater power of 1 or lesser, or neither of the numbers are repeated. So how do I write? Therefore 5005 is equal to 5 into 7 into 11 into 13. So it is just all plain numbers there, none of the numbers are repeated. So this is how you do the prime factorization of the given numbers. Now let us see, once you know the prime factorization, how do we find the HCF and LCM. So children, once you know about how to prime factorize the given 2 numbers or given 3 numbers, let us now see how do you find the HCF and LCM with the help of prime factorization, right? So the question here says, find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the 2 numbers. This is very important result. Now the first number I have chosen very easy numbers, and then we will go to a little bigger numbers. Now children, first of all keep in mind, whenever you have to find LCM and HCF, the important thing is that you need to prime factorize the numbers first, which I have just now told you how to prime factorize them. So the first question is 26 and 91. I will first show you their prime factorization. Preferably I use the vertical method. So the first number is 26, which I am going to prime factorize. So it will give me 2 13s are, right children, and 13 ones are 13, and it ends my prime factorization because I have got a 1 over here. So this part is done. Now let me see the other number. The other number is 91, and I try it by doing. Now here it does not go by 2, neither does it go by 3. Then the next number with me is 7. So what do? 91 I try to divide by 7 in rough. I know 7 ones are 7, and I get 2 over here. So 21, so 7 threes are. So this is how with practice you will understand which number goes, but again preferably give the order 2, 3, 5, 7 and so on. So now directly I am trying 7s are, so 7 13s are 91, and I know now 13, it being a prime number, so I can directly say 13 ones are 13. So this is how it is finished my prime factorization. Now how do I put it? Therefore 26 is equal to 2 into 13. and the other number is 91 is equal to 7 into 13. So, till here it was our basic prime factorization. Now, let us come to see how do you find the HCF. Now, as I have told you, HCF is the product of the smallest power of each common prime factor. Let us first see, children, which is the common factor in both of them. Now, in both of them you will see that 13 is common here as well as over here. So, whenever you are finding the highest common factor, be very much alert about the common factor or rather common prime factor, because that you need to take only once, and it is the product of the smallest power of each. Now, smallest power, now luckily here the power of both of them is 1 itself. So, in this case highest common factor of 26, 91 will be how much, children? There is only one number which is common and its least power luckily is 1 only for both of them, but we don't write it twice, we write it only once. That is why we say common, the one which is common. So, HCF of these two numbers is going to be 13. That is the highest common factor, correct, no children? When I see it over here, the highest of this is 13, the highest of this is 13, and which is common to them? 13. So, highest common factor to both the numbers is 13 in this case. Now, coming to the part of LCM. For LCM, what is the definition? Product of the greatest power of each prime factor. For LCM, you have to take all the prime factors. Also, you have to take the greatest power of each. Now, greatest power of each means here all are having power 1 only. So, that is not a question. So, directly I can write LCM of 26 and 91 will be how much, children? Now, they are saying greatest power of each prime factor. So, I take 2, which is the greatest power here, 2 itself. So, 2. I take 7, which is the greatest power over here, power 1. So, I take 7 as it is. In 13, I have to choose the one which is the greatest power. The greatest power is 1 over here. So, into 13. So, that becomes my lowest common multiple. That is 2 into 13, 2 into 7 into 13, which is 14 into 13. And let me see what answer do I get for 14 into 13. So, 14 into 13 will give me 4 3s are 12, carry 1. 42 plus 4 and 1 and 2, 8. So, 182 will be the lowest common multiple for these two numbers. What did we do, children? We took all the prime factors but the one with the greatest power. Now, here there was no question of power. I will tell you what happens, how does it play a game when you say greatest power in the next sum. So, this is the LCM and HCF. Now, after finding the LCM and HCF, you have to show rather that LCM into HCF is equal to product of the two numbers. Now, we got LCM and HCF. Let us see the product of LCM and HCF. How much do you get? So, now I will say LCM into HCF. How much is LCM, children? LCM is 182 and our HCF was 13. Now, let us see what is their multiplication. So, 182 into 13. 3 2s are 6, 8 3s are 24, 5 plus 2, 8, 1. We are getting 6, 6. So, 2366 is the product of LCM and HCF, which I am going to write over here 2366. So, we got the product 2366, but the next part is the product of the two numbers. Which are the two numbers, children? The two numbers are 26 and 91. So, the next thing we will say product of two numbers. What is going to be the product of two numbers? It will be 26 and into 91. And now again let us verify if 26 into 91 does come to that number. So, for that I will require this space. So, I will try 26 into 91. So, that will give me 6 and 2 plus 4 carry 5, 23 over here. So, you will get 6, 6, 3, 2. So, you are getting 2366. So, here you got 2366. Done. So, this is how you could verify that when you take a product of LCM and HCF, its product is going to be same as the product of two numbers. Children, this is mostly the case wherein there are two numbers given. Whenever three numbers are given, this case is not possible. So, I have taken an easy sum to show you how this is verified and how moreover to find HCF and LCM. Now, let us come to the second sum. Coming to the second sum, the first number is 510. The normal procedure is again to find prime factorization. So, I will do over here 2 2s are 4, remainder 1. So, 2 5s are 10 and 2 5s are 10. Be alert on this, you have to do it mentally now. Now, I know 5 and 5, 10, 11, 12. This goes by 3. Okay, this number goes by 3. Why? Because the number add up to 5 and 5, 10 and 2, 12, and 12 means 2 plus 1, 3. So, that is the divisibility test for 3. So, let us see, 3 7s are 21 and 3 7s are 21, no. So, this will go by 3. So, 3 how many are 3 8s are 24 and 3 5s are 15. Now, this will go by 5. So, I try with 5, 5 1s are 5 and 5 7s are 35 and 17 1s are 17. Finishes my prime factorization. All my numbers are prime numbers. Come to the next number, which is 92. So, I will try with 92, goes by 2. 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6 and 23 itself is a prime number. So, children, so 23 1s are 23. So, children, once this prime factorization is done, we need to put it up properly. So, I will write therefore 510 is equal to 2 into 3 into 5 into 17. 2 into 3 into 5 into 17. Whereas the other number is 92 is equal to, since 2 is repeated over here, I will write 2 square into 23. So, this is the correct way of writing it because of the power we need to understand, because in the definition we talk about power. Now, coming to the highest common factor. We know that the highest common factor means the factor which is common to both of them, but in that you have to take the one with the smallest power. Now, if you look over, children, which number is common to both? Just check. So, the number common to both is 2 over here and 2 over here. That's it. There is no other number common because we are talking about highest common factor. But in the highest common, we have to take the one with the smallest power. Which is the one with the smallest power, children? 2, because 2 means 2 to the power 1. Here it is 2 to the power 2. So, the highest common factor is 2 and done. Now, coming to the part of LCM. For LCM, what do we say? We have to find the product of the greatest power of each prime factor. Which are the each prime factor, children? There is 2, there is 3, there is 5, there is 17, there is 23, and they are saying you have to take the greatest power. In 2, have I taken the greatest power? No, now I have taken the greatest power. Whereas in HCF, you took the least power, that is 2 to the power 1, which we anyway see is equal to 2. So, get the difference between the lowest power and the greatest power. Here we take all the numbers, but the common ones we take with the greatest power. Now, we have to find what is that LCM. For that, we have to multiply many things, children. So, 4 into 3, this is going to give me 12, and this is going to give me 5, and this is going to be 17, and this is going to give me 23. And 12 5s will give me 60. So, I will do 60 into 17 into 23. Let us see what do I get. So, I will do 17 multiplied by 60. It's easier. 6 7s are 42, carry 4. So, 1020. Just check. So, 1020, and this I need to multiply by 23. So, 0603 plus 0402, let me see, 06432. So, my answer here in this case for the LCM is going to be 23460. So, after multiplication we saw that the LCM is 23,460, huge number. LCM is always bigger, HCF is highest common factor. So, we take only the common, whereas we take the lowest common multiple, and because it is a multiple, there are most of the numbers to be taken, and hence the answer comes very huge. So, this is how you do the second one. Hopefully, your doubt about the smallest power, greatest power is understood in this. But in the second one, we have to again prove LCM into HCF. So, that we will try here. let us do the first part, that is LCM into HCF. So LCM into HCF will give me, LCM was how much children? 23460 and multiplied by HCF was only 2. So that is easy. So let us see what is the product. So product will be, you can do it mentally, 2 zeros are 0, 6 twos are 12, carry 1, 4 twos are 8, 1 9, 3 twos are 6, 2 twos are 4. This is the product of LCM into HCF. But they are saying the other side should be the product of two numbers. So product of two numbers, when I say, what are our two numbers children? 510 and 92. So 510 and I am multiplying here by 92 just to show you what our answer will be. So 2 zeros are 0, 2 5 twos are 10 plus 9 zeros are 0, 9 ones are 9, 9 fives are 45. So 0, 2, 9, 6 and 4. Yes, we reached to the same number. So LHS is equal to RHS and hence this thing is verified. LCM into HCF is product of two numbers. These were very basic simple sum children. Now I am coming with the sums wherein there are three numbers. So children, continuing in the chapter real numbers and about HCF and LCM, let us now see how to find the HCF and LCM by applying prime factorization. But now in this case there are three numbers. In the earlier case you saw that we have done it with the two numbers. Now coming to three numbers, the first sum. Also children, keep in mind the product of LCM and HCF is equal to product of two numbers is applicable only when there are two given positive integers. That case is not applicable over here. So don't try to apply that formula over here which we applied in the earlier sums. Now coming to the first sum, 12, 15 and 21 are the three numbers and you know that we have to find their prime factors first. So that is the first method. Now I will try with 2. 2 6s are 12, 2 3s are 6 and 3 1s are 3. Factors are complete, easy ones. 15 goes by 3 also and by 5 also, but I always start with the least number first. So it will give me 3 5s are and 5 1s are. Factors done. 21 directly goes by 3, it goes by 7 also, but again try with the least number first. So 3 7s are and 7 1s are. Prime factorization was easy, but then how do you write it over here? So 12, how do I write over children here? 2 is repeated, right? So I will write 2 to the power 2 into 3, correct? The next number is 15, which is but very simple, 3 into 5, and the third number is 21, which is again easy, 3 into 7. So only here you will see that the power of 2 is 2. Again now we have to find LCM and HCF. Now to get LCM, we know, or rather we will go to the HCF first. HCF is the product of the smallest power of each common prime factor. Now let us see children, which is the common factor to all of them? Is 2 common to all of them? No. Is 3 common to all of them? Yes. Is 5 common to all of them? No. Is 7 common to all of them? No. This word is very important, to each common prime factor, right? So here I will do 3, 3 and 3, but we need to take the smallest power. Here there is no greatest power, everyone are having the same power. So HCF in my case, HCF of which numbers children? 12, 15 and 21. 12, 15 and 21 will be how much? 3, because that is the only common factor. But I have chosen the smallest power because all are having power 1. Now coming to the LCM. LCM of 12, 15 and 21. Now what do we talk about LCM? We take all the numbers, or rather all the prime factors. So we take all the prime factors but the product of the greatest power of each prime factor. 2's is fine, 2's power we will have to take 2 only, but common one is 3, we take it only once and its greatest power is 1 itself. So into 3 and into 5 into 7. So what did we do in LCM? We took the greatest power of each prime factor. So we took 2, 3, 5 and 7, but for 2 we took the greatest power. So now here it will become how much, children? 4 into 3 into 35. So that will give me 12 into 35. Let us see what answer do you get for 12 into 35. 12 5s are 60. So 6 carry 6. 12 3s are 36. 36 and 6 will give me 42. So is the answer 420. So 420 is the LCM of the given two numbers. So this is how you do it for three numbers. Let us come to the next set of questions. So now let us come to the second sum. First sum is already done. So second sum, the numbers are 17, 23, 29. But see what's the magic of this, children? 70, 23 and 29. Aren't they all the prime numbers? Yes, they are not divisible by any other number other than they themselves or by 1. So 17 ones are 17, that's it, right? The second one is 23 ones are 23 and 29 is also a prime number, so 29 ones are. So 1 ones are 1 also you can write over here, and hence what are your factors? Your factors are going to be, for 17 it will be equal to 1 into 17. 23 is equal to 1 into 23, 29 is equal to 1 into 29. Done. Easiest sum. But then see what is the HCF. Now for HCF we say the smallest power of common prime factor. Which is the common power here, children? The common number is 1 over here. That's it. The rest are not common. So how much is going to be the HCF? HCF is going to be 1. So keep in mind, for prime numbers the HCF is always 1. So without any other calculation you can directly write the answer for HCF of such numbers as 1. So therefore HCF, that is the highest common factor of 17, 23 and 29 is equal to 1. Coming to LCM. For LCM what do we do, children? For LCM we take the greatest power of each prime factor. Now which are the each prime factor? All prime factors in this are 17, 23 and 29 and 1 is repeated. So 1, even if you write, you don't write, makes no use over here anyways. But 1 into 17 into 23 into 29, and that will give me the LCM for these numbers. So let us see what is the multiplication. And again for LCM you have to be always ready for bigger calculation. So 17 into 23. $391, and then 391, children, I need to multiply by 29. So you get 9 ones are 9, 9 nines are 81, carry 8, 9 threes are 27 and 8 will give me 35 plus 2 ones are 2, 9 twos are 18, 3 twos are 6 and 1 7. So 9 3 3 11339 11339 is the LCM of the given three numbers. So this is how you find SCF and LCM of given three numbers. Now we saw LCM SCF of two numbers and also of three numbers. So continuing in the chapter real numbers, we come to the end part of this chapter, wherein I have come with two word problems. Let us check the first one. It says check whether 6 to the power n can end with the digit 0 for any natural number n. So the value of n can be any natural number, say 0, 1, 2, 3, 4, 5, 6 and so on. But will this digit, whatever is formed, will it end with 0? That is their question. So now to get the solution for that problem, that is our first question, children. First of all, let us see which are those numbers whose last digit is 0. So to check that, let us start with 10. 10 has a last digit 0. But what are its factors? 2 into 5. Right? So its factors are 2 into 5. Suppose if I choose a number 30, then its factors are how much, children? 2 into 6. So it for 30 the factors will be 5 into 6, which furthermore I can write as 5 into 2 into 3. Correct? If I choose one more number, say suppose 500 if I take, children. What do I write it as? 5 into 100, and 100 can be furthermore written as 5 into 10 into 10 or 5 into 2 and into 5 into 2. Hopefully you have understood what I did. 5 2s are 10, 10 10s are 100. So I can write it as 5 to the power 3 and 2 to the power 2. So in a way, why am I doing this is to tell you that whenever there is a number whose last digit is 0, they are having 2 and 5 as the prime numbers, 2 and 5 as the prime factors, 2 and 5 as prime factors. So such numbers only will have their last digit as 0. So now let us talk about 6 to the power n. Now when I say the number 6 to the power n, children, and they said n can be any natural number, so can I write it according to our laws of exponents, 2 into 3 to the power n? Yes, I can write. So what did we see? That its prime factors are 2 and 3. But we know that we need prime factors 2 and 5. Without that, the last digit will never be 0. So what explanation do you give? That all these numbers, they were having 2 and 5 as their prime factors, whereas 6 is having prime factor 2 and 3. So since 6 to the power n does not have 5 as a prime factor, children, it has 2, because we want 2 and 5, 2 and 5. 2 is there, but 5 is missing. That is very important, that since it does not have 5 as a prime factor, therefore 6 to the power n cannot end with digit 0. So it cannot end with digit 0. Right? So this part is important to show the factors. N can take any place, that is not the thing, but every time it will be expressed as 2 into 3. Okay, coming to the second sum, very interesting word problem, and it really tells you how the application of LCM HCF can be in a word problem. Also, I am reading the sum. There is a circular path around a sports field. Sonia takes 18 minutes. So this girl Sonia is taking 18 minutes to drive one round of the field. So one full round she takes 18 minutes, while there is a boy Ravi who takes 12 minutes for the same, that is to complete one full round of the field. Suppose they both start at the same point. So they are starting, say suppose this is the circle they need to complete. So here is where they both are starting. So there is Sonia also starting over here, and there is Ravi also starting over here, and they will complete one full circle. But the problem is Sonia is taking how much time, children? She is taking 18 minutes, whereas Ravi is taking 12 minutes. That is the only difference. So he is taking 12 minutes. But the thing is, they are saying suppose they both start at the same point, that is this point A they are starting, and at the same time also, and go in the same direction. So they are going, say, in the same direction like this, and they come back. But they are saying after how many minutes will they meet again at the starting point. So by going by this time, what they have done, one round she completes, but after how many minutes will they meet again at the starting point. So if at all they have to meet at the starting point, what will be that time? That is what they are asking. Now for such sum, we always make use of LCM, that you have to keep in mind. So first, what do we say? That time taken by Sonia, time taken by Sonia to complete one round, one round is how much, children? It is 18 minutes. Whereas time taken by Ravi for the same thing, right, to complete one round, that will be 12 minutes. Correct? So time is given, but they are asking you at what time will they meet together again. So that time will be decided by LCM of both the numbers. So the next statement will be time at which they both will meet again. Time at which they both will meet again, where children? At the starting point. Meet again at the starting point. So they started at a point A, both together same time in the same direction, they came over here, but one is taking 18 minutes, another is taking 12 minutes, and then they continue like this. They are asking that once they started at the same point, after how many rounds or after how many minutes rather are they going to meet at the starting point again. So they had met at the start and now they want to know after how many minutes will they meet again. So that time at which the both will meet again at the starting point will always be given by LCM of both these number, children, 18 and 12. So LCM of 18, 12 decides the final point wherein they will meet again. So I am taking both the numbers. First number is 18. I will find its prime factors. 2 9s are, 3 3s are, and 3 1s are. Whereas the other number is 12. So its factors will be 2 6s are, 2 3s are, and 3 1s are. Smaller numbers, so work is also easy. Now I will write down 18 as, children, since 3 is repeated, so I will write 2 into 3 to the power 2 because 3 has come 2 times. Whereas I will write 12 as how much? 2 to the power 2 since 2 is repeated, and into the power 3. Till here fine, but we need to find the LCM. And what is LCM? LCM is product of the greatest power of all the factors whichever are there. What do we say? Therefore LCM is equal to. Now as I have told you, LCM will be what? We take all the factors but we take the greatest power of this. So 2 is here, 2 is here, but we take only the greatest power, that is this one. 3 is also here, 3 is also here, but we take the greatest power of all the factors. And in 3 what happens, children, is the greatest power is 3 to the power 2. So don't forget, we do take the common factors, or we rather take all the factors, but the ones which are common, we take only their greatest power. So here it will be 2's power is greatest is 2, and amongst 3 the greatest power is 2. So your answer will be 4 into 9. So it will be 36 minutes. So rather, why we said? Because LCM is going to decide time at which they both will meet again at the starting point. So both of them, when they started at the same point and then they will meet over here again, will be after 36 minutes. So here you have taken help of LCM, which is the main thing in the chapter real numbers like LCM, HCF and Euclid's algorithm lemma. Hopefully the full chapter you have understood very well, children. Thank you so much.